Welcome back to the channel. This week my review of Groundswell 2024. I started day one with John Kempf, Under the Big Top, which, although a basic introduction to John Kempf's plant health pyramid, provided the foundation to his lectures on Thursday afternoon. What was interesting was the standing ovation that welcomed John onto the stage. More from John later. Next, it was Benedict Bossell's insight into transforming a 7,500 acre organic and forestry operation in East Germany.
I kind of grew up in that environment from a little childhood.
He has converted a significant proportion of arable land into agroforestry, but discussed the need to raise rootstock best able to cope with his dry environment.
And this area is really defined by the toughness of the ecosystem.
He achieved this with his own in-house tree nursery. He also discussed the need to gather data to aid decision making and the creation of a foundation to work with interested scientific institutions. Finally, he discussed the battle to improve the small water cycle through improved infiltration rates and the cultivation of more diverse stands of tree species.
Implemented basically 5 different transformation projects as in a way of actually bringing in sort of the scientific monitoring of the actual values of forest, right?
And the reintroduction of abandoned ponds.
And that is, because we have this kind of long land from the ice time, we have some rocks that have melted slower than others. So they have actually formed this level of clay, which means these used to be beautiful habitats for a lot of species like frogs and some reptiles, I guess. And they have incredible value as far as biodiversity and habitat is concerned, because they are kind of stepping stones, and species need those stepping stones to be able to move from A to B. And through the years, of course, because of the weather, but also because of the erosion and the sediment, these have become dried out more and more sand and other things coming in there.
Staying in the study tent, it was a panel discussion chaired by Joe Stanley discussing cover crops. A question from the audience raised the spectre of slug damage in cash crops following cover crops, and an issue I believe we have overcome with regular passes of the stubble rake and weeders.
Thank you very much, Joe. Really, it's about slugs.
We've certainly seen problems where things have gone wrong, but actually, in general, I think when we're in a bit of a system change with no-till, using catch crops, cover crops, our carrot beetle populations are increasing, and that's going to help us out, but it doesn't necessarily stop it being a problem. Where I think we've benefited from drilling, say, catch crops this autumn, specifically anecdotally, there's a pass with the drill, the slug pellets out the back, and we followed up with the rolls. I think that's done a number on the slugs early on. We've then drilled again in the autumn, a small amount of slug pellets, rolls, and we haven't had to go back to those fields.
After lunch, it was an rather interesting double session from Joel Williams, discussing firstly lessons learned from research into mechanisms for building soil carbon, followed by a discussion of biostimulants. In summary, we are best to assist the plant by providing a source of carbon when applying foliar nitrogen.
So again, we're just comparing straight nitrogen with nitrogen plus a little bit of carbon, plus one of these stimulatory compounds, fulvic acid in this example. And so we are comparing how this addition of the fulvic acid compares photosynthesis and nitrogen metabolism, particularly on maize. And they find that the maize yield increased, the nitrogen use efficiency increased, the soil ammonium content increased. Some of these plant growth hormones, auxins, this is very important for root development, but some of these other enzymes that are really important for nitrogen metabolism, for protein synthesis, these are all also upregulated.
And longer forms of biochemical precursors like amino acids as a basis for proteins production.
Now, it turns out that actually plants can use larger, more complex forms of nitrogen, like amino acids, like chains of amino acids called peptides, or like even larger things like those proteins the plant actually can absorb these larger complex molecules. It's not just that the plant can take in these inorganic forms, these small ionic small forms that are very easily absorbed through the roots, which yes, it can do, but it can also take up these larger, more complex things. And indeed, the plant releases specific root exudates called proteases, which specifically help to liberate and unlock some of these organic fractions of nitrogen.
For example, 1 kilo per hectare of amino acids generates growth equivalent to 15 kilos a hectare of ammonia. Finally, he touched on applying phosphorus stabilizing bacteria with soil phosphate applications.
Again, illustrating this point that biostimulants can help us be more efficient with the fertilizers or the other inputs that we do use. And this is a really nice example of that. We are comparing treatments here of applying just a phosphorus solubilizing bacteria, or comparing that with triple super.
More than doubling phosphate availability to the plant. This is especially interesting considering phosphates are insoluble in water and meshed well with the Riso Cycle developed by James White, a message John Kempf would build upon. This diagram of the Riso cycle shows microbes entering the root cells at the root tip and exiting through the tips of the elongating root hairs. Riso cycle microbes alternate between an intracellular endophytic phase and a free-living soil phase. Endophytes are bacteria or fungus that lives within the plant for at least part of its life cycle without causing any disease. For example, nitrogen-fixing rhizobial bacteria living in legume nodules. Soil nutrients are acquired in the free-living soil phase and extracted oxidatively in the intracellular endophytic phase, which is a much better mechanism to explain how plant roots acquire nutrition than the simple ion diffusion gradient model we've seen before. More about rhizophagy later. Thursday started with a panel discussion in the Big Top chaired by Joel Williams. Anna Shorvinska was especially good at describing the stages farmers go through, culminating in farmers contributing to and setting the research agenda. Ed Horton shared his figures demonstrating why including sheep in the arable system made sense, increasing his oilseed rape margins from 876 to 1,260 and increasing his wheat margins from 1,300 to 1,700 pounds per hectare. I really enjoyed a very interactive presentation by Odette Menard.
And what I want the most at the soil surface is that yellow band.
On soil structures. Firstly, she demonstrated how dropping tire pressure reduced pressure at depth.
And we need to find ways to have lower weight per wheel in order not to go across that 50 centimeter line.
She went on to demonstrate how pressure travels deeper in wet soils.
If we work in a dry situation, we are going to impact less our soil. We have the feeling that it has a better bearing capacity. It does. So that's what it showed here.
She also outlined a simple but ingenious method of checking compaction layers within a soil by pulling a curved pruning knife through the sidewall of a soil pit from the bottom to the top. She also pointed out that after 60 centimetres, 44% of roots share the same path with at least 3 other roots. So, if your cover crops are deep rooting, this is the mechanism by which the following cash crop benefits. She used this photo of a tillage radish to demonstrate the mechanism by which plants move soil to the surface in order to push roots down, demonstrated by the raised collar of soil around this radish root. Odette concluded with a mirror of Joe Stanley's cover crop discussions. Cover crops need to be treated with the same level of thought and establishment care as cash crops. She used the acronym CROP: care, rotation, oxygen, porosity. My final presentation was a John Kempf doubleheader on the conditions required to climb the plant health pyramid. John's plant health pyramid presentation is available through the AEA YouTube channel, and I have included a link in the description below. Stage 1, complete photosynthesis increase in both quality of carbohydrates measured through BRIC scores and the quality measured by production of complex carbohydrates. Plants become more resistant to soil-borne fungal pathogens. This is thought to happen as a result of plants improving the quality of the root exudates. This can be achieved by ensuring an adequate supply of the following 5 photosynthetic minerals: magnesium for white water hydrolysis enzyme cofactor and the element at the center of the chlorophyll molecule, iron needed for synthesis of chlorophyll, and phosphorus to metabolize ATP as part of the photosynthetic process. We have increased magnesium application on the farm as a result of sap analysis. I was particularly interested to hear John's anecdote about different growers and increasing the green in plants. Farmers use nitrogen, turf growers use iron, and horticulturalists use magnesium. We now apply foliar nitrogen and magnesium, so I guess the next step is chelated iron. Stage 2, complete protein synthesis. Nitrogen converts to complete proteins, so no trace of ammonium or nitrates remain in plant sap. This helps to explain an issue I have seen in our sap analysis. Although we have only applied very low levels of foliar nitrogen, there appears to be excess levels of nitrates and ammonium in the sap. Fortunately, John went on to resolve this paradox. Complete protein synthesis enables the plant to become resistant to sucking insects. This is because the insects can only digest simple amino acids rather than complex proteins. Excess levels of nitrates and ammonium in sap can be addressed with adequate levels of magnesium, sulfur, molybdenum, and boron. The magnesium product we use contains sulfur, but we haven't added molybdenum or boron to date. As we have used more foliar nutrition, we have run up against a new application issue. As we use a contract spray operator to apply our plant protection products, we sometimes struggle to apply foliar nutrition at optimal timings and rely on tank mixing with herbicides. This can result in mixes which scorch or damage the crop leaves. We also recently lost access to a local facility we have been using to liquefy urea for foliar applications. I was therefore really pleased to see this tow and fert foliar applicator. Compatible with spreading up to 24 meters, it is designed to spread both compost extract and foliar urea and is capable of dissolving 600 kilo bag of urea in 15 minutes. In addition, the 4,000 litre tank would give us extra capacity to spread foliar nutrition independent of herbicide and fungicides, which should have a timing and plant health benefit. Here is some footage of our on-farm trial following seeing the machine at Groundswell. Back to John Kempf. The first 2 levels can therefore be resolved with chemistry, but this changes with level 3 and 4. These levels need strong biology activity within the rhizosphere. Stage 3, increase in lipid synthesis, dependent on good biological activity. plant fat or lipid levels can be increased to 5 to 6% of a dry matter basis, resulting in a waxy shine on the leaves. A plant can use up to 60% of its photosynthetic energy to simply convert nitrate to amino acids, a massive drain on energy levels. Alternatively, plants can absorb amino acids secreted by microbes directly from the soil profile, saving a significant amount of energy. Achieving level 3 provides resistance to airborne fungal attack. Stage 4, increase in plant secondary metabolites, i.e. essential oils, protects plants from insect attack. These are the plant's proactive defense mechanism. These are often triggered by beneficial microbial interactions. Plants will be better placed to resist beetles and nematode attacks at level 4. Well, that's my review of Groundswell. Sorry it took so long to put together, but John Kempf's presentation took a little time to digest. If you like this video, please give it a thumbs up, subscribe, click on the little bell to get notifications of when our next video goes live. Not long till harvest now. See you next time. Bye.